Good morning, students. Yesterday we have learned about the system of units and the SI units. Today we will discuss the topic dimensions of the physical quantities. So what are the dimensions and what are the dimensions formula and the dimensional equations? So now what are the first of all we would like to discuss the dimensions of a physical quantities. So you know that there are mainly two physical quantities. One is fundamental physical quantity, which is also known as base physical quantity, and another is uh, a derived physical quantity. And this derived physical quantity, it depends on the fundamental physical quantities, or we can say this derived physical quantity is the combination or the repetition of a fundamental quantities, and these fundamental quantities are seven fundamental quantities, and they are referred as a dimensions, and each fundamental physical quantities are given a particular dimensional symbol. So these physical quantities, we can say that this dimension, what are the dimensions? So in fact the dimensions of a physical quantity are the powers or exponents to which the fundamental physical quantity are raised to represent that quantity. Or in simple words, we can say that a derived quantity is a combination of combination two or three or four uh, fundamental physical quantity. If one fundamental quantity which is uh, included in that derived physical quantity is repeated. For example, if length is repeated, length means length is there for two times, then length into length, it means L2. 2 means the power 2. So the 2 is the dimension of a particular fundamental physical quantity, length. So we can see the dimensions, like dimensions and the symbol. First of all, we will see the symbols of the dimensional symbol of the fundamental physical quantity. So you can see the table which is given in this sheet. So that is mass, and for number one is mass. So SI unit of the mass is kilogram, and the dimensional symbol is given in bracket, that is m. So this symbol is always, we will write this dimensional symbol in a bracket. So the length, the SI unit of the length is meter, and it is or the dimensional symbol is L, and the time SI unit is second, or the symbol is S, and the dimensional symbol is T, and the electric current, the dimensional the SI unit of the electric current is A, and the dimensional symbol in is also A, but it is in bracket. On the thermodynamic temperature, the SI unit is Kelvin, and the symbol is K, and again the dimensional symbol is in bracket K, or you can also see the theta also in bracket in some books. So both are correct. And the luminous intensity, this is candela, and the SI unit symbol is CD, and again this dimensional symbol is given in bracket in CD, or the I also is there in the bracket. And the amount of substance, this is the seventh fundamental physical quantity, which has the SI unit mole, and this mole is written in bracket. So it is the symbol, it will be the symbol of this amount of substance. So these are the dimensional symbol of the fundamental physical quantities. Now, how we will write these dimensions and what are these dimensions? In general, in any physical derived physical quantity, which depends on these seven fundamental units, fundamental physical quantity. So these fundamental quantity is uh, mass, length, and time. The mass, length, time, electric current, temperature, luminous intensity, amount of substance. So out of these seven physical quantities, which these physical quantities is included in that derived physical quantity. These derived physical quantities to be that if three physical quantity is included, then we will say that it has the three dimensions or three dimensions of the fundamental physical quantity. So if we the dimension formula and the dimensional equation, then these physical quantity written in a combination of the fundamental physical quantity, and some fundamental quantity repeats itself in this derived physical quantity. So we will write these physical quantity in form of dimensional symbol after raising the powers or the exponents in combined form. Then it becomes a dimensional formula of a derived physical quantity. So you can see here that, for example, in the m to the power a, l to the power b, t to the power c. So these powers or exponents raised to the fundamental physical quantity is known as the dimension of that particular fundamental physical quantity. You can see here that m to the power a, l to the power b, t to the power c. So the here a is the dimension of mass m and the b is the dimension of physical quantity l and c is the dimension of physical quantity fundamental physical quantity t. So now this combined form written in combined form m to the power a, l to the power b or t to the power c. We can say power here. Power in mathematics we will say power, but the here we can say the a is the dimension of m, b is the dimension of l, t is the dimension of uh, c is the dimension of t. So this is known as dimensional formula. So now if we uh, will think about the dimensional equation. So dimensional equation is also a dimensional formula, but when we write the when fundamental quantity on one side and the dimensional formula on other side, then this becomes a dimensional equation. So this, for example, if we write the dimensional equation of a velocity or a speed of an object, then it will be the velocity or the speed is equal to distance upon time, and that is equal to L upon T. So L is the length and time is T. So L, because L is here for a single time, so uh, L1 and by T, so then T is minus 1, so LT minus 1. So LT minus 1, or we can say M0 L1 T minus 1. So and if we write it in a combination or a combined form or in a bracket, then it becomes a dimensional equation for the physical quantity and derived physical quantity speed. Here again we can say the m to the power 0, and this power, not a power, but we can say this is the dimension 0. So the m, the 0 is the dimension of m. It means this speed is has dimension of length is 1 and the dimension of time is -1. And likewise, if we write the dimensional equation of acceleration, so it is equal to velocity upon time, and we have dimensional equation of speed, and that is speed of the velocity, that is L1 t minus 1 upon t. So again Lt minus 1 upon t, so then t to the power minus 2, so it becomes m0 L1 on t minus 2. And again, if the derived physical quantity force, and we know that force is equal to mass into acceleration, so this mass into mass is m, it is in bracket, and we can say the acceleration, that is Lt minus 2, L1 t minus 2, so it becomes L1 m1 L1 t minus 2. So this is the dimensional equation of force. So here the uh, dimension of mass is m, and the dimension of L is 1, and the dimension of the t is minus 2. So likewise we can write the dimensional equation of each uh, derived physical quantities. So we can have a table of these derived physical quantity, and if we know the formula of different derived physical quantities, we can write it easily, and so you can do the practice and you can write it easily. Then we have, this is also noteworthy here, that if the physical quantity which is having the same fundamental quantity, then the dimensional equation of the these derived physical quantities are also same. So now today's topic is over. If anybody wants to call, or um, then you can raise hand, otherwise this is over. So the topic is over. Thank you.